In this lesson, we are going to take a look at Viry-Skin material or Viry-Skin MTL. Viry-Skin material is a subsurface scattering material like ViryFast SSS2, but it was specifically developed by Kiosk Group for rendering skin. We are going to be working with the scene. We have this head model here, a few lights, and a backdrop. I don't want to talk about the lighting right now. First, we go through the very basics of skin material and then develop a realistic skin shader for the model we have. And in that part, I will also describe the lighting approach for this particular scene. So let's get back to our camera view and open up our material editor. Add a Viry-Skin material to the active view and assign it to the head model. Skin material is composed of a few layers: a diffuse layer, a shallow scattering layer, a medium scattering layer, a deep scattering layer, also a primary and a secondary reflection layer. So from the overall contribution of all of these layers, we get our final skin material. We are quite familiar with the diffuse and the reflection layers, but what are these three scattering layers? Shallow scattering is for subsurface scattering that happens near the surface of the skin or the epidermis layer of the skin. Mid scattering goes deeper in the skin, and it is for the SSS layer that happens in the dermis layer of the skin. And finally, we have the deep scattering, which goes further and controls the subsurface scattering behind the skin for blood and tissues underneath the skin. That is why, by default, it has this red blood-like color. Also, if you take a look at their radius values for these three layers, the shallow scatter radius has the smallest value because it happens very near to the surface of the skin, and mid and deep scatter can go deeper in the skin. So the rule of thumb here is that the radius values for these three layers should increase as we go from shallow to deep scatter. Because if the radius value of the shallow scatter layer was bigger than the radius of the deep scatter layer, for example, I have replaced my shallow scatter layer to be the deep scatter layer. So remember this rule. Now that we have this base knowledge, let's start exploring the parameters of this material. First, we have scale, which scales the subsurface scattering effect up and down, and it works as a multiplier for the shallow, medium, and deep scattering. Let's take a look at a few renders with different scale values. In the first one, scale was set to 0. And as you can see, we have this color of the shallow scattering layer, but the scattering effect is not noticeable. Then we have 0.5. Now we start to get scattering effect in the ear and nasal areas. Then scale was set to 1, sorry. Then 2. And as I increase the scale value, we simply let the light to penetrate further through the object. Then we have 4, and finally 8. Okay. Now let's set the scale back to 1. Next we have max SSS amount. The shallow, medium, and deep scattering have this amount right now. The shallow amount is 1, the medium amount is 1, and deep amount is 0.4. Max SSS amount is the maximum limit for all the contributions from the subsurface scattering layers. If the sum of the individual shallow, medium, and deep scattering layers exceeds the max SSS amount value, the amounts are renormalized so that their sum is the same as the max SSS amount. Now let's see a few renders. In the first one, max SSS amount is set to 0. So we basically cancel out all the three layers of scattering. And right now, because our diffuse amount is also 0, we only get the contribution from our two reflection layers. The next one is set to 0.2. And now the max limit for all these scattering layers is 0.2. So we get some scattering effect, obviously. The next one is 0.5, and finally 1. This value is basically like a percentage of how much subsurface scattering from those three layers we want. Next we have max reflection amount, and this one limits the total contribution of the reflection layers to the specified value here if the sum of the primary reflection amount and the secondary reflection amount exceeds this value. The amounts are renormalized so that their sum is the same as the max reflection amount. We have two reflection layers, a primary and a secondary layer. Normally the primary layer should have a bit blurrier reflections and the secondary layer is shinier. Right now only primary reflection layer is on and secondary layer has an amount of 0. Let's set it to 0.5 here, and max reflection amount limits the total contribution or amounts of these two layers. Let's for now set the max SSS amount to 0. So we only deal with the reflection and take a look at a few renders. In the first render, max reflection amount is 0, so basically no reflection. Then it's set to 0.2, 0.6, and 1. Because the Fresnel option is enabled for the primary reflections, we don't see much change from 0.2 to 0.6 or 1. When Fresnel is on and we have a fairly low IOR value like 1.3, the reflections are going to be weak in the frontal or parallel angles to our viewing direction, even if we have a very bright reflection in the perpendicular angles. But if you zoom into this neck area here and go between the renders, you can see this increase in the reflectivity as we have increased the max reflection amount. Obviously, if you find the concept of Fresnel confusing, please check out the first lesson of this section again. Let's set both the max and max SSS amount and max reflection amount back to 1. We have opacity to control the overall visibility of the object. When set to white, the material is fully opaque, and as I make the color darker, the material becomes more transparent. And at black, we have a fully transparent material, and you can see that in the material preview. In the diffuse rollout, we have diffuse color and diffuse amount. Diffuse color is obviously specifying the color for the diffuse layer, and this is the substantial, palpable color of the skin. Now, what color or texture you use and the amount of it really depends on the lighting, your model, the skin type you're looking for. For now, let's just try a few values for the diffuse amount with this current diffuse color and get an understanding of how the diffuse layer contributes to the whole material. In the first render, diffuse amount was 0, then 0.2, then 0.5, then 0.75, and 1. You can see in the normal range of 0 to 1, as we increase the diffuse amount, we add more diffuse contribution to our material. If you remember when we were working with the very fast SSSS2 material, diffuse amount was working as a mixer between diffuse and subsurface layer, and there at diffuse amount of 1 we wouldn't get any subsurface scattering. But we clearly here, even at diffuse amount of 1, we still get both the subsurface scattering and diffuse contribution. And in a production workflow, it's rare to increase diffuse amounts more than 1, honestly, even more than 0.6, 0.8, but you can do so. And in the next render, diffuse amount was set to 10, and now the diffuse layer is taking over completely, even though it's not physically correct here. Now let's set the diffuse amount back to 0 for now. Next, we have our shallow, medium, and deep scattering layers. Let's start with the shallow scatter layer and zero out the amount of the mid and deep scattering layers. What we have right now is just the shallow scattering. First, we have color, so I can change the color of the subsurface scattering that happens near the surface of the skin. If you take a look at this render with only shallow scattering, you can barely see any scattering, and what is there is very close to the surface of the skin. The shallow radius is 0.1 centimeter right now, so we only let the light to scatter beneath the surface of the skin for only 1 millimeter. That's why subsurface scattering is barely visible here. But still, the defined shallow color is sitting on top of the skin without any noticeable scattering beneath the surface. If we are talking about human skin, the overall color for the shallow scattering, and I want you to really pay close attention here as I'm explaining what sort of colors and texture you should be using in the shallow, medium, and deep scattering layers, as we are going to be using this information later on in the lesson when we are going to be developing a realistic skin material. So as I was saying, if we are talking about human skin, the overall color for the shallow scattering should be very generic and skin-like with not much of detail. If we use a texture here, right? So the color should be generic, and if we use the texture should be, it should be very less detailed compared to our medium layer, for example. Because the actual skin details should be in the mid scatter layer. Now let me change the shallow scatter layer to a green color, like 104 for red, 128 for green, and 42 for blue. So in the render, even though we don't get any noticeable subsurface scattering, but because right now we have no diffuse medium or deep scattering, the color defined here is the dominant surface color of this material. We have shallow amount, which specifies the relative contribution of the shallow scattering layer to the material, or the weight of this layer and how much it contributes to the material. When set to 0, we only get reflection as there is no diffuse and other scattering layers are off also. Then we have this render with 0.5 and finally 1. We have shallow radius, which specifies the distance that light is scattered within the shallow layer in centimeter. Basically, the distance that light can travel through the surface of the skin before exiting. Lower values produce less scattering and the skin can appear more opaque. Higher values give a large sense of translucency. Now, in the first render, shallow radius is 0.1. Then 0.5. Then 1. And finally 5. So as I increase the radius, I am allowing the light rays to travel further through the surface and therefore having a more obvious translucent or subsurface scattering effect. Now, as this is the radius of my shallow scatter layer or shallow scattering layer, I should limit the radius so the light only scatters near the surface of the skin. Now let's set the shallow radius back to 0.1 here and the shallow color to its default value of 198, 154, and 139. We have mid scatter layer, and this goes deeper in the skin, and if you compare this color to the color of our shallow scatter, as you can see, it is more saturated and less generic, and we can also use a detailed texture instead of a color here. Let me just turn the medium scattering layer by increasing the amount to its default value of 1. In the frame buffer, the first render was done with only shallow scattering, and the second one with both shallow and medium scattering. Medium scattering radius is set to 0.5, which is compared to 0.1 of our shallow scattering layer, allows more scattering beneath the surface. One thing you should remember is that these layers are absolutely interchangeable. So if I set the shallow scattering radius to 0.5 and medium scattering radius to 0.1, now we have changed the place of our shallow and medium scattering layers. Finally, we have our deep scattering layer, which controls the main color of our SSS effect. In this case, and SSS, by the way, is obviously, is for subsurface scattering. Now, in this case, because we are dealing with human skin, that color would be a very saturated red. If we were to use a texture for this layer, it would have less detail compared to the mid-scatter layer, but with a very saturated defining color of the whole subsurface scattering effect. Perfect. And you can see its radius is 2 centimeters and goes deeper compared to our 2 previous layers. So let's set the amount of this layer to 0.4, which is the default value, and take a look at the resulting render. Now we can clearly see that with our deep scattering layer, we get more translucent and more saturated effect. Let's increase deep amount from 0.4 to 1 and see what we get. In the frame buffer, you can see the render is more saturated and even more translucent compared to the previous one. Now, to make it clear how this layer is contributing to the final effect, let's set the shallow scattering color to a pure green color, medium scattering color to a pure red color, and deep scattering layer to a pure blue color. If you take a look at the resulting render, you can see in the deepest areas, like inside the ears or nose, we see the deep color, which is blue. The red medium color can be seen near the skin, and the shallow green tint is right on the surface of the right side of the face as the main light is coming from the other side. Now, to prove what I said about how these layers can be interchangeable, let me change the place of the medium and deep scattering layers by setting the medium radius to 2, which is the current radius of the deep layer, and deep radius to 0.5, which was the radius of our medium scattering layer. Now, if you take a look at the resulting render, we have replaced medium and deep layers. Compared to our previous render, the blues are red and the reds are blue. Now let me just delete this material and apply a new skin material to the object. Next we have our primary and secondary reflection rollouts. We have these 2 layers of reflection because different layers of skin might have different specular and reflective qualities. If you notice the reflection glossiness amount for these 2 layers, primary glossiness is 0.6 and the secondary glossiness is 0.8. So the primary layer is always going to be blurrier and secondary layer is going to be shinier and less blurry. For now, let's set the max SSS amount to 0 so we can deal with reflection layers. The set of parameters in both primary and secondary reflections are exactly the same. We have reflection color, which is the color of the primary reflections here. Let's set it back to the default white. Primary reflection amount is the overall contribution of this layer to the whole material. Basically, this is the strength or the weight of this layer. Let's set it back to 1 here maybe. Reflection glossiness controls how sharp or blurry the reflections should be. Values closer to 1 will result in sharper reflections, and values closer to 0 will produce blurrier reflections, and you should be very familiar with these concepts. Reflection subdiv controls the overall quality of the glossy reflections, and increasing this value will make the reflections cleaner and the render slower. We have Fresnel, and when enabled, reflections will be based on the Fresnel rule, which we discussed in the first lesson of this course, and we got the Fresnel IOR value to control the strength of the Fresnel effect, and lower values will result in stronger Fresnel effect. And because skin is mostly water-based, 1.33, which is the IR of water, is a great IR number to use here. Now let's increase the amount of the secondary reflection layer to 1. And as you can see from the preview, we get a secondary sharper reflection layer on top of our primary layer. Now let me show you two renders. In the first render, we only have primary reflections. And in the second one, both primary and secondary reflections. Having these two reflections together is normally the right way of doing things. For now, let me set the second reflection amount to 0 and continue with the rest of our parameters. Also, let's set the max SSS back to 1. A multiple scattering options rollout is exactly what we had in the fast SSS2 material. So you can check that lesson if you are not quite sure what these options are doing. You can check out our lesson, our previous lesson actually. We have this ray traced scatter texture. This option controls whether the textures for the subsurface scattering layers are taken into account when computing the scattering. Turning this option may lead to more accurate results, but adds quite a bit of render time. To see how this option works, let me use this grid.png image as my shallow, medium, and deep color texture. Right now, this texture is overriding these colors completely. So let's come down to the map section and decrease the effect of these textures to 50%. Now also the colors are kicking in. Now we can take a look at two renders with ray traced scatter textures on and off. In the first render it was off, and in the second one it was on. And you can see how the texture is looking different in these two renders. Now let me turn it off for now. Also, let's change the texture amount back to 100. You can also delete the texture here. Now, in the options rollout, we have trace reflections, which enables tracing of reflections from the primary and secondary reflection layers. And when disabled, only highlights are computed. Max reflection depth specifies the maximum reflection depth for the primary and secondary reflection layers. And reflection cutoff allows the user to skip the calculation of very dim reflections and the contribution of which is below the cutoff value here. Now it's time to use this skin material and develop a realistic skin material for our model, and that's what we are going to be doing in the second part of this lesson. First, I'm going to walk you through the lighting that I have in the scene, and then we start developing a realistic skin material. For now, let's apply a simple V-Ray material to our head model. Let me close the material editor and change my viewport to a quad layout. Now let me just adjust all these views a bit so we can see our lights better in the scene. Also, let's open the light lister so we can see the most important attributes of each light in the scene. Let me run the active shade also. Maybe we can close the history panel to save some space. Now, turn off all the lights in the scene. The first and the most important light that we have is our main light that is coming from the right side in a fashion that's called split lighting in photography. It has a cool color and a multiplier set to 20. The next light is our fill light that is coming from the right side of the face, and if I turn off the main light and turn on the fill light, you can see how it contributes to the scene. It has a multiplier of 0.7 and a warm color to balance the kind of cool color from our main light. Now we can turn on the main light to see what these two lights are doing together. Next we have this backlight, which is positioned behind the head, and if I turn off the main and fill light and turn on this light, you can see how it works. It has a multiplier of 5 and a white color, and I specifically positioned it here so we can see the scattering effect better in the material that we're going to be developing. Now let's turn on our main and our fill light as well, and that is what we get from these three lights. And finally we have a dome light in the scene. Let me just turn off all the other lights and turn this one on. And this one is just an overall fill light and a way to get more rich reflections on the face of the character. Finally we can turn on all the other lights, and this is our final lighting. We can go ahead and maybe stop the active shade here. Now just to show you the map we are using for this dome light, select the dome light and open up the material editor and drag its texture to the active view. Click on view image, and this is the map we are using, which is a free HDRI from hdrlabs.com. You can find this one there. And as you can see, its overall multiplier is set to 0.5. Now let's close all these extra windows and start working on our skin material. First, we can delete these old materials, create a new skin material, and apply it to the head model. The first thing to do is to apply the shallow, medium, and deep scattering textures. So let's start with the shallow color and choose Bitmap. You have this folder in your images folder called head. We have this diffuse texture, which is our main color texture. Let's use this one. If you remember when we're talking about different scattering layers, I mentioned that the shallow scattering layer is generally more generic and less defined. So let's add some of this desaturated brown shallow color to the mix by decreasing this map contribution to 50% in the maps rollout. Perfect. Now if we render the scene with just this map in the shallow scattering layer, render 0,1 would be the result. And we barely see any texture or any detail, and this is exactly what we want for this layer. Next, let's connect the same map or texture to the medium color texture. We already know that the medium scattering layer is the layer that should have the most detailed texture. So that's why I'm not going to do anything with this texture and leave it like it is. And if you render the scene now, the result would be render 0,2, and we have introduced a lot more detail compared to our previous render. Let me just make the medium layer go a bit deeper by increasing the medium radius to 1 cm, and the result would be render 0,3. Maybe it's a bit more, it's too much translucent, but we can come back and adjust these parameters later on. For the deep scattering layer, as you remember, we need a defining saturated red color, but the texture should be less detailed compared to the medium scattering layer. First, let's create a duplicate of the diffuse.png texture. Let's open up a preview window for this texture. The first thing is to make it less detailed by maybe increasing the blur offset to something like, let's say, 0.05. I think that's maybe a bit too much. Let's try 0.03. That's good. Now let's close this preview window here. I want to make this map to have more saturated color. So let's add a color correction map to this texture. And increase its saturation to something close, maybe to 70. Let's say 67. But we still don't have that defining red color. So let's add a V-Ray color map. Change its color to 161 for red, 18 for green, and 11 for blue. To combine this texture and this map, or this color here, let's add a composite map. We can define the texture as the first layer, add a second layer, and connect V-Ray color node to this layer. Change its blending mode to multiply and its opacity to 85. Now let's connect this map to our deep texture and render 04 would be the result of the current network that we have. What I want to do right now, as I soon will be utilizing the diffuse layer and it will hide some of the scattering effect, is to make the deep layer more prominent, and we'll be doing that first by decreasing shallow and medium amount to 0.2 and increasing deep amount to 1. Also, as it appears from render 04, the translucency is a bit too much, so let's decrease the radius amount maybe 4 times for each layer and see what we get. So shallow radius 0.025, medium radius 0.25, and deep radius can be something like 0.75. We could have done the same thing simply by decreasing the scale value up here to 0.25, and it would have been the same result, which is render 05. So this render is our subsurface scattering layer in general. Next, we can work on our diffuse layer. So let's use the same map from our shallow and medium scatter, which is diffuse.png, and connect it to the diffuse texture input. And let's try a few diffuse amount and see which one gives the best result. The first one was done with diffuse amount of 0.2, then 0.4, 0.6, and 0.8. I think we can stick with 0.6 here. Even 0.4 I think can work, but 0.6 would be better. So let's set the diffuse amount to 0.6. For the primary and secondary reflection, let's use this map, which is reflection.jpg, and press open. First, we need to invert the map itself. As you can see, the white colors and the black colors are inverse to what we want. Now let's connect it to the secondary reflection texture as well. and the primary one. Also, let's select the map itself and change the filtering to summed area to keep more detail in the image. Set the primary and secondary reflection amount to 0.3. This should be enough. Primary reflection glossiness maybe to 0.5, a bit blurrier compared to its default value, and reflection glossiness of the secondary layer can be 0.65, just a tad sharper compared to the primary glossiness, obviously. And the result would be render 0 sex. We might need to adjust the reflection later on, or we can take a few renders with different reflection amounts. But for now, let's continue on. The next thing would be to turn on scatter GI, and the result would be render 0.7. Now it's time to add some geometric detail using displacement snapping. So let's select the head model and add a viewer displacement modifier. Use displacement.png as the map. Change the mode to subdivision. Set the amount to 1.25 centimeters and shift to negative 0.65. I've worked with this map and I know these values work just fine. Also, let's set the edge length to something like 1. And the result would be render 0.8. We get all these imperfections and details on the face, which is amazing. The next thing we are going to do is to make sure that places with hair, like the eyebrows here, wouldn't be that translucent. We are going to be doing that by controlling max SSS amount using a black and white map. Where it's white in the map, max SSS amount would be 1, and where it's darker, max SSS amount would be smaller. So let's use SSS amount.jpg. And the result would be render 0.9, where, as you can see, the eyebrows are more defined compared to our previous render. I think this would be enough for this lesson. Let's go to our frame buffer and take a look at the final render. You can simply right-click on these images and choose Load Viewer Settings to load the render settings that was used for any of them. And as you can see, we have a pretty nice and detailed render. We definitely can work on it, improve upon the textures, work with the parameters and adjust them and see which one is going to work even better. But for this limited amount of time that we have, I think the result is pretty good. And I encourage you and invite you to go ahead and start, adjusting these parameters and see if you can come up with a better render than what we have right now, which I'm sure you can. I have another render in which I increase the primary and secondary reflection amounts to 0.5, and in this one the face looks to be a bit more wet. And in the third render, primary and reflection amounts was set to 0.85, and in this one our character is literally sweating. We also have our denoiser pass, or subsurface scattering pass as well, and other passes that you can check them out. Let's just get back to the RGB pass. I'll be saving out these renders, and let's apply some color corrections as well. Maybe we can play around with curves and add a bit more contrast. We can enable our color balance, maybe make the shadows a bit bluer, something like 0.08, and the highlights a bit warmer, maybe 0.04. This could be a nice image to save. For another image, we can maybe enable white balance and set the temperature to something like 3000, so a very cool sci-fi image. For another one, we can disable white balance, enable hue and saturation, and desaturate the image completely and save it out. It's up to you really, and you can achieve better results in Photoshop, but you can do some great post work here too. So in this lesson, we learned about Vari skin material. I will see you in the next lesson.